Good everybody and welcome to Turning Point Tutorials lecture. Today we're going to discuss something special as in chemistry. And you all know that chemistry in Turning Point is divided into different sections. We have the Chem 001, Chem 002 and Chem 003. However, today we're going to deal with something important in Chem 003. And Chem 003 is all about organic chemistry. Organic chemistry is the topic of today. And the question is, what is organic chemistry? Organic chemistry is defined as the chemistry of the compounds of carbon except the carbides, except the oxides of carbon, except the trials of carbonate, and as well as the cyanose salts. All these are the exceptions. Organic chemistry. What is organic chemistry once again? Organic chemistry is defined as the chemistry of the compounds of carbon. There are some exceptions. What are those exceptions? Except the oxides of carbon, except the carbides, except the cyanose salt, as well as the triazocarbonate. Let's look at it this way. When you come to the exceptions, I'm referring to those compounds of carbon that are not going to be discussed, that we won't discuss when you come to organic chemistry. Look at compounds like carbon 4 oxide. These are exceptions. Carbon 2 oxide. These are the oxides of carbon. When you come to compounds like you have sodium carbide, you also have that of you have CaCO3, that is triazocarbonate 4 salts. These are now one again compounds of carbon. You also have compounds like, let's say, sodium carbonate. All these are compounds of carbon. There are other compounds of carbon that are also regarded as organic compounds too. So for example, you talk about CH4. We also have C2H6. All these are compounds of carbon. Why? Because these compounds, they contain carbon, but some of them are actually not part of the. They are the ones we call the exceptions. Oxides of carbon, CO2, CO, CaCO3, Na2CO3. All these are the exceptions. But however, this is an organic compound, and CH4 is methane, an organic compound. C2H6 is an organic compound. So we now say once again that organic chemistry is the chemistry of the compounds of carbon except the oxides of carbon, except the triazocarbonate, and as well as what the cyanose salts and the carbides. Let's now come to another aspect. You know very well that organic compounds are very much more in number than the inorganic compound. But we must consider the reason why we are studying organic chemistry. Organic chemistry, as you consider it as a subject, as a topic in chemistry, why are we studying it? Because the importance. Number one, the reason why we study organic chemistry because it is the chemistry of living things. Number two, because organic chemistry, the knowledge you get from it actually has very so much uses in humanity. Considering the knowledge you get from organic chemistry, what are those things you will use the knowledge of organic chemistry to do? It helps us in the production of some useful things like cement. Like what? Cement. You also have perfumes. We can also talk about the issue of drugs. With knowledge of organic chemistry, you can also produce other things like those plastics you have in your rubber and so on. There are very many. And now let's now come to something very important. Like I said before, organic chemistry, organic compounds are so much, they are multifarious worldwide. And to actually understand their characteristics and their behavior, to understand how they react, how we can study them very well. That's why they have to group them into different classes and different sections. But before we talk about the classification, let's come to something important first. An important element in the study of organic chemistry, that is carbon. Carbon. Why is carbon so important in the study of organic chemistry? Carbon is important in the study of organic chemistry because of some reasons. What are those reasons? What are those importance? Why is that carbon so important in organic chemistry? Number one, we talk about the ability of carbon to form numerous compounds. Very many compounds, so much, very much in number. And why is it that carbon is able to form numerous organic compounds? For some reasons too. Because of the exceptional ability of carbon to catenate. That's what we call catenation exceptional. Number two, we come to another reason why carbon is able to form numerous organic compounds. Look at it again. Carbon is able to form numerous organic compounds because it has the ability to form bonds. It has the ability to form bonds with the atoms of other elements. Like for example, let's see an example here. We consider carbon dioxide. Carbon can form bond with oxygen. It can form bond with, like in the case of methane, CH4. It can form bond with hydrogen. Like in the case of what you have the case of ammonia. In the case of, let's say, hydroxy, it can form bond with COH, and it can form bond with other elements too. Now come back again to another important aspect that is very much we should not forget. Now that aspect, another reason why carbon is able to form numerous organic compounds, because carbon has the ability to form multiple bonds. Carbon atoms has the ability to form multiple bonds. For example, carbon double bond, carbon double bond, carbon triple bonds. Now let's come back to another important aspect in organic chemistry. That is actually the organic compounds and their characteristics. Organic compounds and their characteristics. What are organic compounds? Organic compounds are compounds that are naturally found in plants and animals, and naturally found in plants and animals. And these compounds, since they are naturally found in plants and animals, let's now see how we can understand their behavior. Generally, now we consider the aspect of the characteristics of organic compound. What are the characteristics of organic compound? Number one, all organic compounds are insoluble. All organic compounds are insoluble. We can say most of them, let us not say all generalized, but most of organic compounds are insoluble in polar substances like water. They are insoluble in polar substances. And again, all organic compounds, they are highly inflammable. They can easily catch fire. They can easily get inflamed. They are highly inflammable. Number three is considering the reactions of the organic compound versus the inorganic compound. You now see that the organic compounds, their reactions are much slower than that of the inorganic compound. The reactions of the organic compound are much slower when compared to the reactions of the inorganic compound. That's another character. And again, you consider another aspect again, another characteristic of organic compound. Looking at organic compound, they have low melting and boiling points. Once again, I say they have low melting and boiling. Let's consider the case of, let's say, that of palm oil. That low melting and boiling points. Come to the issue of, let's say, things like kerosene and petrol, low melting and boiling points. All these are some of the characteristics of organic compound. There are still other ones, but we now come to the reason why we classify organic compound. Now, see, scientists study very well this organic compound. They saw that some of the organic compounds, they have similar characteristics. They have the same behavior. They have similar character. Those ones that have similar character, they just put them together and place them in one group. This one that has similar characteristics, they put them together and place them in one group. Some of them have similar, so they're not also key. Let us now do something about this grouping of organic compound. When you group organic compounds, you give it a name. There's a particular name, but generally each group of organic compound is also called family, and that word for family in chemistry, organic chemistry, is what we call homologous series. So we are considering another aspect here is homologous series. Homologous series. The question is, what is homologous series? Homologous series is defined as the family of organic compound which follows a regular repeating pattern in which successive members or consecutive members of the series differ in molecular formula by CH2 group. They differ in molecular formula by CH2 group, or they differ in atomic mass, or in I can say they differ in mass by 14 units. They differ in molecular formula by CH2 group or by 14 units by mass. Now let's come back to another word again, the statement homologous series. Homologous series also means family. I can redefine again. Homologous series, simply, it is actually the word is a family of organic compounds that follow a regular repeating pattern in which successive member of the group or the series differ in molecular formula by CH2 group. Now come back to the different examples of homologous series. Before we talk about the examples of homologous series, let us now consider the characteristics of homologous series. The general characteristics of a typical homologous series. Number one, all members of homologous series of a series, they conform to a general molecular formula. All members of a series conform to a general molecular formula. For instance, now we consider Arcane is one of the homologous series. Arcanes, I'm just giving the example first, but Arcane, being an example of homologous series, has a general molecular formula. So I say once again, all members of a homologous series conform to a general molecular formula. I want to give a rundown. Number 2, consecutive members of a series, they differ in molecular formula by CH2 group. Number 3, members of a series has different, they have the same method of preparation. Then when you consider again number 4, the type of reaction, members of a homologous series have the same reaction type, although with varying vigor. Number 5, when you consider a homologous series, when going down a series, the members of a homologous series show some physical characteristics. The physical state of matter changes as you go down the homologous series. For example, from gas state to liquid state, and then from liquid state to solid state. I say once again that when going down the homologous series, physical state of matter changes when going down the series. That is from gaseous state to liquid state, and from liquid state to solid state. I'm just giving a rundown. And the next one is that when going down this homologous series, another thing you see is that the melting and the boiling point increases. Melting and boiling point increases. Then the next one is that when going down the homologous series, the solubility in water as well as volatility increases. There are some reasons, I will just take that one later. Let's come back again to what I said before, the examples of homologous series. There are various examples of homologous series, and the examples of homologous series are one of them is the alkane. Alkane is an example of a homologous series. And the second name for alkane is also called paraffin. Second name for alkane is also called paraffin. Then number 2 is alkane. Alkane is another example of a homologous series, and the second name for alkane is also called olefin. And the third one is alkyne. Alkyne is also it has another name which is also called acetylene. Then the next one is the alkanol. Alkanol is also known as the alcohol. Alkanol or alcohol. Then you also have that of number 5 example of a homologous series is the alkanal, which is also known as the aldehyde. Also called the aldehyde. And then the next one is alkanone, which is also known as the ketone. The next one is the alkanoic acid, which is also called the carboxylic acid. The next one is also the alkanoate. Alkanoate is also called ester. It's also called known as ester. Another example of homologous series is the alkanoyl halide. The next one is the you also have that of you have the alkanoid halide, alkanoid. Once again, I said alkane, alkanes, alkyne, alkanol, alkanal, alkanone, alkanoic acid, alkanoate. We also have the alkanoid halide. We also have the alkanamide or alkane amide, or I call it alkanamide. They also have the next one, which is called the alkoxyalkane. Alkoxyalkane is also called ether. Alkoxyalkane is also known as ether. Alkoxyalkane is known as ether. Another name for it, not ester. The next example of a homologous series is the alkyl halide. The alkyl halide is also called known as haloalkane. haloalkane is also called the alkyl halide. There are still more examples to talk about. Let me just give another one is called the amine. Now, amine is also there. But you know, amine has the various category. You have the primary amine, secondary amine, and the tertiary amine. But let's do that one first. The next example is also called the phenol. There are so many examples. We also have the acid anhydrides, and then the phenol, epoxides, and so on and so forth. But let's just leave it there. There are so many examples to give as examples of the homologous series. Now, like I said before, the first time, the characteristics of a homologous series, the typical characteristics of a homologous series. One of them, I said that all members of a homologous series conform to a general molecular formula. Now, the table below will give us the general molecular formula of these homologous series. Some of them are just listed, not all, because of time. Now, because we cannot finish everything now, we just want to see how we can break it down step by step. But let us just see quickly, because we need to have a full grasp of everything. Now, the table below shows various types of homologous series, some of them, not all, and their general molecular formula together with their functional group. That's why I will still discuss another thing called functional group. Homologous series, general molecular formula, and then their functional group. Homologous series, general molecular formula, and then their functional group. And then we'll see the name ending. But this table is going to help us. Just take note of this table. Very, very important. Very, very important. And you need to make use of this table when you are referring to some things later. Now, considering this table, we have just this very four columns here. Now we have the homologous series. First of all, at this first column here, homologous series. The general molecular formula. General molecular formula. Then we also have the functional group. Functional group. And then we also have the name ending. Okay, since I've written the word that very aspect functional group in this table, it means I have to give you a definition for the functional group. Now, for every homologous series apart from the alkane, there must be a functional group right there, so we can understand what to do or the reactions, the reaction that you should know about that very homologous series. Now we talk about the first one, which is the alkane. Alkane is one of the homologous series. It's also called the paraffin, and the general molecular formula for the alkane is CnH2n plus 2, or at times we can write like this, ROH. ROH, where the R, that R means something. It means the alkyl group. It means alkyl group. Alkyl group. This R means alkyl group, and that word alkyl group. How can we know or understand anytime you see the structure of an alkyl group? How can we understand? Now, for every alkane, there you will see that if you should remove any alkane you are breathing, if you should remove hydrogen from it, you have an alkyl. Now, the alkyl group is the R part of the alkane. Then, removing the hydrogen from an alkane, an alkyl is formed. So the R means alkyl group, and the H added to it makes it an alkane. So this and this are also the same. Now, the next thing to understand here is that the functional group. The functional group is, there's no functional group for alkane. Now, the name ending here is "ene." Let's see the next one. I will buttress this aspect later. I will go into details when it comes to the aspect of the alkane. But let's continue to the next. Let's move to the next one. Alkene. Alkene is also called. Remember, it's also called the olefin. But we'll come to details when we discuss the alkane very well later on. Now, what is the general molecular formula for the alkane? For the alkene is CnH2n. Then, what is the functional group here? It is carbon-carbon double bond. Carbon-carbon double bond. Or you can write like this: carbon carbon double bond. That's how to write it, how to pronounce that. And the name ending is the in. The next aspect to talk about is the alkyne. The alkyne, you know quite well. The alkyne is also called the acetylene. So for the alkyne, we have the general molecular formula to be CnH2n minus 2, and the functional group there is a carbon-carbon triple bond. Carbon-carbon triple bond. Carbon-carbon triple bond. That is the functional group for the alkyne. Carbon-carbon triple bond. Then the next aspect is the name ending, which is the ine. Ine. When we get to the aspect of the nomenclature, you see how we apply that later. Then again, we talk about that of the alkanol or alcohol. We have alkanol having its own general molecular formula as CnH2n plus 1 OH. The OH is the hydroxy group there, or we can write like this, ROH. And what is the functional group? The functional group for that is the hydroxy group, which is the OH, and we could spell it this way, hydroxy group. And the name ending is ol. Well, because of time, we'll still want to we end somewhere like then we can still take 2 more or 3 more. We can look into the alkanol, and alkanoic acid. We'll see how we can just end it there. For the meantime, then we'll continue when we come again. Let's see that of the alkanol. For the alkanol, it has its own general molecular formula, and the general molecular formula for the alkanol is as simple as anything. RCHO. I just make it so simple, very short. But the R there represents the alkyl group, but CHO has to do with the aldehyde group, But let's see how it goes right now. We can restructure it this way. We can write like this: O, R, double bond, O, and the H here. But I can write like, you can also read like this: R, C, then the double bond O. I can even put it down like this, it's okay, it's accepted anyhow, but as in as much as we have the CHO, that's the hydroxy group there written, then we are good to go. Let's now see what is the functional group here. The CHO is the hydroxy group. Actually, not the hydroxy group, sorry, the aldehyde group. The aldehyde group. And what is the name ending? Al. For that of, let's consider the alkanol. The alkanol we know before is also called the ketone. Alkanol or ketone. And what is the general formula is RCOR, and we can also write like this: R double bond, RC double bond O, and R here. And what's the functional group is called we call it the keto group. That's the functional group, the keto group. Come like this, written this very way, double bonds, or can we write like this: C double bonds and like this as a keto group. Call it the keto group. Well, ladies and gentlemen, because of time, we just want to have a stop here for today. We will continue, we'll meet again. Thank you very much. Just go through what you have learned.